So for this experiment, we will determine the concentration of acetic acid in vinegar. It's a classical titration experiment. So the first thing is I'd like to introduce you to this glassware. It's called a burette. So the burette is going to dispense the material. We're going to fill it with NaOH, and then we will titrate it with the vinegar. The vinegar is going to be in a beaker down here. Before we do all of that, let me just show you how to manipulate this long piece of glassware. Again, it's called a burette. Right, so you're gonna, it's in your lab, it's gonna be left like this upside down to dry. So we will just put it here. Okay. So these are your markings, the volume markings. One important thing I want to tell you guys is you want to read this to 2 decimal places. So whatever volume you read it to 2 decimal places. Before we begin this experiment, let's wash the burette. So this burette is going to be filled with sodium hydroxide. So I'm just going to take about 5 mils of sodium hydroxide and just clean this. All right, so about 5 mils. Okay, this is just a very quick cleaning of the NaOH. Okay, this is 0.25 moles per liter. Okay, we'll just pour it in here. Sometimes we can use a funnel, that helps. Okay, this is just 5 mils, and I'm just going to clean this. The way I like to clean it is just kind of coat it. Okay, so you want to do this about 3 times, so just coat it and then dump it into a waste beaker. Okay, you can do this in the sink with the water running, or you can dump this into a pre-designated waste beaker. So I'm going to do this 2 more times, fill it in with 5 mils, clean it, the insides, and then after that, so you want to do this about 3 times, I already did it once. So after that, we will begin our titration experiment. All right, so let's begin our titration. One thing I want to mention, this long tube is called a burette. It's a 50 ml, 50 milliliter burette. And what I usually like to tell students is when you're measuring out the volume that's going to go into your beaker, it's easy if you just fill this up all the way to the top. If you fill it up all the way to the top, then you know you have 50 milliliters here. So that's what I'm going to do. So I'm going to fill it up all the way to 0.00. Right? So that's the top volumetric marking here. Okay, 0.00. Let's see if Larissa, you can film that. Okay, so that's the top, excuse me, and 0.00. Okay, you want to read this to 2 decimal places. Right, I'm going to switch this back to me. So it just makes it easy when you do when you're measuring out the volumes. So let's put our flask in here, and we're going to fill it up to 0.00. So make sure this thing is turned this way. Okay, so you want the stopcock. Okay, so this turns on the stopcock, this turns the stopcock off. So I had it on, so now it's off. Now the volume will stay. So let's fill this up. Be slow and be careful. Okay, that's a little bit too much, so I'm going to take my waste beaker. So you want to kind of hold this, and I can come one by one to show you, but I like holding it and holding the stopcock with my thumb and my first finger. I hold the part of the burette here just to get a good motion so I can control the volume. And very, very slowly, you got to get a knack to this. Very, very slowly get this so that the meniscus is at the bottom, and there. Okay, to my eye, that's what it is. I'm going to turn this around, and let's see if Larissa can get that. So this is at 0.00. It's touching the marking, it's touching the volume line. Okay, so I'm going to put this towards me. Okay, so you know, a burette doesn't mean it's exactly going to dispense 1 mil, 1 mil, 1 mil. You got to read it to 2 decimal places, but it's really meant for fast. It's really meant for a very fast recording of volumes that's going to how much of this is going to react to what I put in here. And for this experiment, what I'm putting in here is the vinegar. All right, so we got our sodium hydroxide in. That's called the titrant. This thing here at the beaker is called the titrant, and according to the protocol, it's 50 milliliters of water. So let me pour out 50 milliliters of water. Okay, I'm going to use a graduated cylinder. So graduated cylinder, let's pour that to about 50. And 5 milliliters of vinegar. Okay, so once again, I want to repeat, this is the titrant. The thing in our burette is called the titrant. So we can pipette this in here. So always be slow and be careful. There is no rush whatsoever. That's about 5 ml, so let's put that in here. All right, and lastly, we're going to put a dye. Okay, and the dye here is phenolphthalein. So just 2 drops. It's just a dye. It's going to give it a color. So that when we know when all of the NaOH titrant reacts with all of the vinegar titrant, we'll get a color change. So the only thing this does is give us a color indicating when the reaction is complete. Okay, so the protocol calls for 2 drops. That's 1 drop. Here's another drop. And that is the indicator dye phenolphthalein. Let's give it a good mix. And now we're ready to start our titration. All right, we are ready now to begin our titration. So let's go ahead and start. I'm going to do 1 ml at a time. So we are going to dispense 1 ml, about 1 ml, and then shake it. You got to be very, very patient here, as it may take a while. So now I dispensed another 1 ml for a total of 2 mLs, and we're going to keep on doing this. All right, set it to a volume level of 3. Keep on shaking it. It doesn't have to be exact. Okay, that's the point of a titration. It's not exact, but whatever you read, you want to read this. Whatever volume you read, you want to read this to 2 decimal places. Right, so when do we stop adding the NaOH that is in our burette? We stop when this thing turns the slightest pink. Okay, when it gets too pink, a lot of students do this. In fact, I'm guilty of it as well. When it gets too pink, you've overshot. That is, you've added too much sodium hydroxide. So you want to be very, very diligent and slow here. The protocol says 1 ml at a time. You may even want to go to 0.5 mils at a time as you begin to see the pink stay for longer durations. But right now you do see the pink, but as I stir it, it goes away. So there'll be a point where I stir it and it still remains pink, but you want it to remain a very light pink. Okay, don't overshoot it. If you overshoot it, then you won't be able to get the right answer that tells you how much acetic acid is in this vinegar, which is the overall goal of this experiment. All right now I'm at 12 mils. All right, I think I'm going to go to 0.5 mils at a time. This may take a long time if you do this lab. Oh, maybe I overshot it, but yeah, okay. So let me read this out, and I'm going to turn it around so that Larissa can record the volume. But I'm getting, remember, read it to 2 decimal places. So I'm going to say 17.70, okay? Maybe 17.71. Let's see if Larissa can zoom in. Okay, the way you read this may be different than the way I read this. I have goggles on, so that could also obscure things. So I'm going to call that 17.70. I think I kind of overshot it. I kind of wish I got it a little bit less pink, but that's okay. So 17.70 is what I'm going to call that. Notice I'm reading the burette to 2 decimal places. Now, why is this 17.70? Because I started at 0.00, went all the way down to about 17.70. So that is how much of this NaOH reacted with this acetic acid. All of it reacted all of it reacted because the indicator turned pink. All right, so the second part of this experiment, we will do a pH titration. So remember, in our first part of the experiment, we did a titration, and in my value, I got 17.70 milliliters reacted with the acetic acid totally, reacted totally with the vinegar, because it turned a blue color at that volume. So in this next set of experiments, we're going to actually put a pH electrode. So this is an electrode that measures pH. So we're going to take this out of the container solution. And so this is the actual pH electrode. Okay, you can take this lid off or keep it on, it's up to you. I usually like to take these CHEM wipes, these little white tissue papers, they're called CHEM wipes, and wipe it. You don't want this to dry, that's why we always keep it in its storage electrode solution. All right, and then we will store it or just keep it right here. Okay, so now this already has our 50 mils of water and our 5 mils of vinegar and our 2 drops of phenolphthalein like we did before. And I've already filled up the burette to 50 milliliters. I filled it back up to 0.00 of our sodium hydroxide. So the only difference now is when we do our titration, we're going to measure the pH. So this is our electrode. It's connected here to a Go link, this little something that connects this to the computer. So this end gets connected. All right, so this is to the pH meter, connected to the Go link. And then this end gets connected to the hard drive at the back of your computer. You'll see this when you do the lab. All right, so now we're ready. We've connected the pH electrode to the link, and that's connected to the back of the computer. So we're going to click on Chemistry Labs to actually acquire our data. So click on Chemistry Labs, and you'll see a whole bunch of different programs here. You're going to want to click on pH versus volume. Okay, so for those of you that are doing this live, click on pH versus volume. I'm going to switch to a running application because I already have this loaded. We can exit out of that. And this is what you want to see. Okay, so at the bottom you have your pH. The x-axis is volume. Now if you read the protocol, they want you to go from 0 to 30 milliliters. So the way you're going to do this is you're going to zoom in here. Okay, so you want your cursor to have this shape. Okay, once you have the cursor at that little crossbar shape, you can see I can adjust it to 30 and then simply hit enter. And then the pH, you want it from 0 to 15. So I'm going to go to this topmost number. You notice my cursor is this little bar or shaped like a capital letter I. I'm going to do one click. Okay, go all the way up. And the pH is, the protocol says 0 to 15, so I'll change that to 15. So some of you, depending on which lab station you're in, may have to adjust the pH axes. All right, so we are set. If I can get Larissa to just slowly turn in. We have our apparatus here, 50 mils of NaOH. You see our pH electrode is connected to the computer, and we're ready to measure the pH. So I'm going to do this 1 milliliter at a time, and the pH should get registered. Okay. Now I haven't added anything yet, so the first thing you want to do is click collect. Okay. All right, so click collect. And then after you click collect, this is important, after you click collect, you're going to go keep. And then the volume that you're going to add, okay, I didn't add anything. Okay, so it's going to be 0.00. Make sure you read it to 2 decimal places. Whatever you put in and whatever input you put in here, you put it into 2 decimal places. I didn't add anything, so it's 0.00. Click on OK. All right, so that's my first point. Have Larissa zoom out here, and you can actually see the pH is 3.64. All right, so I'll have Larissa film me do a couple of these runs, and then the overall goal here is to get the shape of the titration curve. Do a little bit of shaking. Okay, you want to read this to 2 decimal places. To me, this is 1.01. So let's go back here. Let's mouse over to keep. All right, so go back down, and the volume I added 1.01. All right, click OK, and there's my second point. All right, I'm going to have Larissa film me do maybe 4 or 5 of these, and then we'll just follow in real time the shape of the pH curve. The pH curve should be something like this. It should go steady, steady, and then shoot up, and then stabilize. Kind of like a shape of an S, except the S is a little bit deformed. So let's go ahead and do maybe 4 or 5 more of these, and then we'll watch this in real time. All right, our next one here, 1 ml at a time. Don't need to be so exact. And this is about 2.01. Okay, 2.01. Okay, so I added 1 ml, but the total is 2.01. So let's go back to keep. The total volume is 2.01. Okay, total 1.01 before, and another one I just did now. The total is about 2.01. That's what I read from the burette. We're going to click on keep. Let's keep on doing this. Now, one thing I do want to mention, in my first titration, it was about 17.70 milliliters. That's what I got. Your data and your numbers may be different. So I'm going to keep going up to about 5 milliliters before that. So about 12, I'm going to continue to do this 1 ml at a time. Once I reach 12, which again is 5 milliliters below my 17 that I got in my first titration, then I'm going to go slow. I'm going to go slow, maybe about 0.5 milliliters at a time. All right, so I'm going to keep on going 1 ml until I reach 12. And then you can actually do this pretty fast. There's no compulsion that you have to try to get 1, 1, 1, 1 each and every time. This one is 3.11. Okay, so let's go back here. 3.11. So you're going to keep on doing this. Okay, let's do about 3 or 4 of these, and then we'll have Larissa monitor our computer in real time. I'm getting here 0.90. Okay, so let's go back here. Keep total volume I added so far is 3.90. Notice I'm recording this to 2 decimal places. Whatever I'm reading from the burette, I'm reading it to 2 decimal places. That's the most important thing. 4.98. Don't worry about the color of the solution in the beaker. It's going to turn really pink because we're going to go all the way till the highest pH. Okay, so we're just monitoring sort of a pH profile. Let's do a couple of more, 1 ml at a time. Uh, 12.01. I'm almost close to 5 minus that, so I think what I'll do is I'm going to go to 13. Then after 13, I'm going to go 0.5 mils at a time. Because in my first experiment, I got 17.7. 17.7 minus 5 is about 12.7. I'm going to go to 13, and then after 13, .90. So you can see here that from here in this regime, I added 0.5 milliliters increments near the equivalence point. Now the shape of the curve is such that it's going to be kind of like an S-shaped curve or sigmoidal. And I'm adding 1 milliliter increments here to make it go a little bit faster, but eventually the pH is going to plateau. So this is a kind of a nice shape. Okay, right here is my equivalence point, so around here is when everything sort of reacted. And you can actually see the color is pink here. And now I'm just waiting for this to level off. Okay, that is the nice, correct shape of a pH titration curve. So I'm going to add 1 milliliter increments here till I see it start to level off, till I see it to start to become more of a horizontal shape. Right, so almost done, and also my pH is around 13.28. So the scale is about 0 to 14. So I'm going to just continue to add, I'm guessing around 5 or 6 more points. And right now I'm just looking for the right shape. It's just about the shape of the pH curve. 25.00. I'm going to do about 2 or 3 more times. I kind of like the shape of the curve now. Again, it's all about how the pH curve looks like. When the curve looks good, we can get good data from it. 27.03, I'm going to call that. All right, one more. And our last 1 mil increment is 28.01. All right, so this looks pretty good. Okay, our nice pH curve. Around here is our equivalence point, and we're going to figure that one out now. Right now, since we are done, this is very important. Since we are done, we're going to click stop. Okay, so no more data collection. I click that red stop sign, and now we're ready to do our final bit of data analysis. All right, so now we got our nice titration curve. You're going to have to do this twice, okay? So I'm going to do this once. I'm going to do it again, but I'm not going to film it. But for those of you that are doing the lab with me, I'm going to have you do this a second time so you can get better data as you average the equivalence points. But let's get our equivalence point for this one, our first titration using the pH electrode. Remember, the equivalence point is when all of the titrant, the thing in the burette, reacts with all of the titrant, this thing in the beaker. So all of the sodium hydroxide reacting with all of the acetic acid. So to get the equivalence point here, we're going to go to the y-axis label, which is pH. Okay, all you got to do is click on it. It's a left click and go to the first derivative. All right, go to the first derivative, and that is, the equivalence point is the volume at which this is at its highest. So an easy way to do this is if you click on one of the data points and go to graph options and click on connect points. Okay, so I had to draw a line, and now I'm going to mouse over here to the topmost part of the graph. And the topmost part of the graph, it actually tells you the volume, and that's 20.43 milliliters, and that's what I'm going to write down for my data. Okay, your data may be a little different. That's okay. Your data is yours, and my data is also mine, and everyone's going to be a little bit different. But you see how I moused over here, hold it with my mouse, and then you go here to the x and y coordinates. We're interested in the x coordinate because the x coordinate is the volume. 20.40 milliliters. So I'm going to write that down in my notebook and data table. Actually, the first derivative and the second derivative should actually be the same or close to one another. So let's left click and let's do our second derivative. All right, the second derivative is where it crosses the x-axis. So I'm going to shift this. So we can, there's two ways to do this. One is I'll just click on the 0 and make it -5 or -2, or you need to shift it down. All right, so the scale is shifted and where it crosses the x-axis. So I'm going to thumb over in my mouse where I think it crosses the x-axis. And wow, look at this. Where it crosses the x-axis for the second derivative is 20.40. It was the same for my first derivative. Usually what I tell students to do is average. Okay, average the second derivative volume, in this case 20.40, with your first derivative volume. In that case, let me go back to our first derivative. The peak is at the same thing, 20.40. So I tell students to average. Okay, you want to mouse it over. That's about 20.40. Average the two, first derivative and second derivative, average those two volumes, and that's the volume that you want to put as your equivalence point. So we got our equivalence point, 20.40 milliliters for our first titration. Let's do this again. Repeat the exact experiment one more time to sort of get a better average of our titration data. And after that, we will go through our data analysis to figure out the molarity of acetic acid in this vinegar sample. All right, so here's the data for our second titration. This is the duplicate of our first one. Notice the shape is really nice. I also want to bring your attention, something really weird happened here. Notice it's a little deviation from the overall contour of the shape, but that's okay. You see this point here and this point here. Something was off when I did the titration, but this belabors the point that you're looking for the overall shape. Okay, so if 1 or 2 points are a little bit off when you do the measurement, that's okay, because we're only interested in the overall shape, and this should have very minimal effect on our equivalence point calculations. So here's the shape. The equivalence point is going to be somewhere around here. Let's get a more better value. Like we said before, in our first trial run, this is the second of our duplicate. To get the equivalence point, we're going to go to our first derivative, and that is where it's maximum. Oh, by the way, let's hit stop first. So we finished the experiment. I finished it, so I'm going to click stop. Okay, now we're at our first derivative. So we're going to see where it hits the maximum point. Now, to make it easier, we can connect the dots. So graph options, connect the points. Hit done. And like before, we're going to mouse over. Let's see what Larissa can see that. And I moused over to that top point, 18.4. Let's see here. The mouse is touchy. 18.42. Okay, so we're going to average that with our second derivative value. Okay, this is what I have students do. I have them average the first and second derivative because they should be the same. Now our second derivative is where it crosses the x-axis. So where it crosses the x-axis, let's put some, let's make this axis limits from -5 all the way to 15. So where it crosses the x-axis is right here. So let's see if Larissa can mouse in on that. And then that is 18.46 milliliters. So I got 18.42 and about 18.46. So average those, and that will be the equivalence point for the second titration.